Mann Whitney U test is used to test the equality of two location parameters. Here, the location parameter is the median. So we want to see that whether the median of one population is the same as that of the other population. Now here the point we need to consider is that if we are getting two samples to prove this kind of hypothesis about equality of two medians, then we need to see that whether there are certain ties in the observations. Now what do we mean by the ties in the observations? Let us suppose an observation is repeating itself like 2 times, 3 times or 4 times within the sample and across the sample. That means if we are talking about sample 1 and sample 2, then within the sample 1, an observation may be repeating itself, or it may also appear in the second sample. So I would be giving you an example through which you would be taking the demonstration onto the testing hypothesis about equality of two location parameters. Now I'm taking a real life problem, so I would be stating it for you. The objective of the study was to determine whether there is a significant difference in the median life expectancy of smokers and non-smokers. A sample of 38 smokers and 40 non-smokers were chosen at random, and their age at death was recorded. You are required to test at 5% level of significance that the median life expectancy of the two groups is same. So here we are given with two kind of data sets. One sample is about the smokers and the other sample is about the non-smokers. And we wanted to compare the median life expectancy of both of the groups. Now, in order to carry out this problem, this data is being given before you. The left side 4 columns, they are about the non-smokers, whereas the remaining 4 columns, they are reporting the life expectancy among the smokers. Now, students, as you can see that there are certain values that are repeating themselves. For example, for instance, if we are looking for non-smokers data, then 77 observation is appearing here, and it is also appearing one more time under the same sample. If we are looking across the sample, then again you can observe that this 77 number is also appearing twice under the smokers data as well. Now here you would have to consider that if there are less number of ties across the sample, then we may not be using the Mann Whitney formulae for corrected for ties. But if there are more ties across the sample, we need to take up that formulae. But as you can see that most of the observations, they are showing a kind of ties within the same samples. So we are going to take up this problem and we'll see that whether we can ignore the ties or we can keep on the ties and we can correct those ties under the Mann Whitney U test formulae. So students, here in order to follow this kind of hypothesis, सबसे पहले जो हमें करना होता है pair of hypothesis design करने हैं. So under H0, we would be testing that non-smokers and smokers have the same median life expectancy. Whereas under the alternative hypothesis, we are going to test that their life expectancy, median life expectancy is different. Step number 2 is the level of significance, and as you can see, it is being mentioned as 0.05. Under test statistic, we are going to use the normal approximation, reason being that both of the data points, they were greater than 20. So if you remember, we have discussed that if N1 or N2 would be giving you the total number of observations more than 20, then we might not be using the Mann Whitney U test formulae. Rather, that Mann Whitney U test would follow the normal approximation. So I'm going to use the normal approximation. So students, formula is Z equal to U minus E of U. That is the mean of the U, and sigma U is the standard deviation of the U. Where what is U? As we know that there were two kind of groups. So initially we would be calculating U1, and now we are going to calculate. It may be calculated as R1, rank sum of the first sample, minus N1, the total sample size of the first sample, into N1 plus 1 by 2. Similarly, we would be calculating the U2. Now let me tell you students that what is this R1 and R2 and how we are going to calculate that. As we have discussed earlier, that we need to arrange the observations from smallest to the largest. So students, arrange करने के बाद आप दोनों sample size को combine करेंगे, smallest to largest observations को आप arrange करेंगे into certain magnitude from smallest to the largest. Once you have arranged all the observations collectively, they would be forming single group, और उसके बाद आप उसको ranks assign करेंगे. Smallest value को आप lower rank देंगे, और जो आपकी maximum value होगी उसको आप highest rank assign करेंगे. Once you have assigned the ranks collectively to both of the groups, then you would have to separate them out. और सेपरेट करने के बाद दोनों रैंक्स को आप उनको सम अप करेंगे, उनके रैंक्स को. सो पहले सैंपल के जो रैंक्स का सम आएगा, दैट विल बी R1, वेयर एज द सम ऑफ द रैंक्स फॉर द सेकेंड सैंपल दे विल बी कॉल्ड एज R2. Now the next thing we would have to do is to follow this data for the calculations. The first thing you need to do is to calculate the mean of U. So expected value of U may be calculated as N1 into N2 divided by 2. Whereas the formula for sigma U is N1 into N2 multiplied by N1 plus N2 plus 1 divided by 12. Now students, I have already calculated the rank sum for the first data after arranging the observation from smallest to largest and then separating them out, summing those ranks. I've got the rank sum for the first population sample as 1854, whereas the rank sum for the second data is 1227. Once I have done that, I would have to calculate U1 and U2. So U1 में students देखिए ये आपके पास है R1 minus N1 N2 divided by 2. So I've got 1034 as the final value of U1. Similarly, I've calculated the U2 and the value is obtained as 486. Now I'm going to use this U1, U2 to follow the Z test. But before that, I need to calculate expected value of U and sigma U. So expected value of U will be N1 into N2 divided by 2. So I'm getting a value of 760. Similarly, I've calculated sigma U. Sigma U was calculated as positive square root of N1, which is 40, N2, that is 38, and N1 plus N2 plus 1, that is 40 plus 38 plus 1, that gives me 79. Dividing it with 12, I've got the value of sigma U as 100.0333. Now I'm going to use all these values to calculate Z. So Z is U. Now U is 486. Now how I'm going to calculate U? Students, as I was given with two values, एक U1 था मेरे पास और दूसरी U2 था. अब U1 और U2 में जिसका रैंक सम मिनिमम होगा, you would be collecting that value. So U 486 was the lower value. इसको मैंने subtract किया मीन में से and I've divided it with sigma. So I've got this Z value as minus 2.73. अब स्टूडेंट्स यहाँ पे मैंने one of the portion शो किया आपके सामने, table of the standard normal cumulative distribution function. यहाँ जाके मुझे minus 2.7 को, minus 2.7 is the row और third is the column. आपने minus 2.7 row में जो कि Z की वैल्यू है, इसको थर्ड कॉलम में जो आपने लोकेट किया तो आपके सामने नजर आ रही है ये वैल्यू 0.0032. This is your p-value on the basis of which you are going to reject or accept the null hypothesis. So critical region is that we need to reject our H naught if our probability value of the p-value remains less than alpha. So as we have calculated the p-value as 0.0032, so it lies under the critical region. That means it is less than 0.05. So H naught will be rejected, and we will conclude that there is a significant difference between the life expectancy of smokers and non-smokers.